Hello friends, welcome to my channel LahariLectures. In this video, you can watch notes on multi-threading models. Threads may be provided either at the user level for user threads or by the kernel for kernel threads. User threads are supported above the kernel and are managed without kernel support, whereas kernel threads are supported and managed directly by the operating system. The three common ways to establishing such a relationship: multi-threading models. First one, many to one model. Second one to one model. Third one, many to many model. First one, many to one model. The many to one model maps many user level threads to one kernel thread. Thread management is done by the thread library in user space. So it is efficient. The entire process will block if a thread makes a blocking system call. Also, because only one thread can access the kernel at a time, multiple threads are unable to run in parallel on multi-core systems. Green threads. A thread library available for Solaris systems and adopted in early versions of Java used the many-to-one model. However, very few systems continue to use the model because of its inability to take advantage of multiple processing cores. Many to one model, user thread, kernel thread. Second one to one model. The one to one model maps each user thread to a kernel thread. It provides more concurrency than the many to one model by allowing another thread to run when a thread makes a blocking system call. It also allows multiple threads to run in parallel on multi-processors. The only drawback to this model is that creating a user thread requires creating the corresponding kernel thread because the overhead of creating kernel threads can burden the performance of an application. Most implementations of this model restrict the number of threads supported by the system. Linux, along with the family of Windows operating systems, implement the one-to-one model. One-to-one model, user thread, kernel thread. Third one, many to many model. The many to many model multiplexes many user level threads to a smaller or equal number of kernel threads. The number of kernel threads may be specific to either a particular application or a particular machine. The many to many model suffers from neither of these shortcomings. Developers can create as many user threads as necessary and the corresponding kernel threads can run in parallel on a multiprocessor also. When a thread performs a blocking system call, the kernel can schedule another thread for execution. Many to many model, user thread and kernel thread. One variation on the many to many model still multiplexes many user level threads to a smaller or equal number of kernel threads but allows a user level threads to be bound to a kernel thread. This variation is sometimes referred to as the two-level model. The Solaris operating system supported the two-level model in versions older than Solaris 9. However, beginning with Solaris 9, the system uses the one-to-one model. Two-level model, user kernel, kernel thread. Thanks for watching. Please like, share and subscribe my channel and support my channel. Thank you.